Hi guys, welcome to INSECTECHS, and this is class 2 of Nmap topic, and in this class we are going to learn how to work with Nmap tool. Most of the times, let me clear the screen. So most of the times you will be working with Nmap commands only. It is a very good habit to learn Nmap tool on commands instead of working with GUI, that is Nmap. So let me type sudo -i to become a root user. Type a password and hit enter. Let me split vertically. So we have 3 windows over here, and we have 3 virtual machines running. One is Metasploitable 29.157 is the IP address, and another one is server 2019, which is 29.14. So -scan -l. So as you can see, we have 192.168.29.1, which is the router IP address, 14 Windows 2019, 55 is the host machine, 75 could be my mobile, which is connected to the same Wi-Fi, my another mobile which is connected to same IP address again, and 157 is Metasploitable. So clear the screen. So let me type nmap -help. So there are many options in this Nmap, as you can see in the help, and the usage of Nmap means the syntax of Nmap is Nmap, scan types, options, and target specification. Okay, if you scroll down, this is an example of the syntax like Nmap, a scan type, and the target, or options, scan type, and the target specification. And if you scroll up, you can see under target specification you can pass host name, IP address, networks, and so on. You can give a single IP address, a range, or an entire CID, that is a subnet mask, or you can actually specify file name which contains a list of IP addresses or network information. Under host discovery, you can specify SL, list scan. It is a simple list target to scan. Ping scan. We will use all these options in this class while learning. Scan techniques, so TCP connect scan, and so on. Port specifications, service and version detection, script scan, OS detection, timing and performance, and so on. So let me clear the screen, clear, and let us start. Now let us try to understand how to use Nmap tools in efficient way. To scan the single IP address or a single target system, the syntax is nmap target IP. So to scan a single machine, the command is nmap IP address 192.168.29. say for example 14, which is a Windows 2019 server, and hit enter. Let me also do the same on Linux machine, on Metasploitable machine, and as you can see we got a result nmap 192.168.157. and also let me do a nmap scan on external machine, like example INSECTECHS.in, nmap www.insectechs.in. As you can see, we got a results for various individual IP addresses. When I did nmap scan for 192.168.29.14, that is 2019 server, starting nmap with the version number, time, and the nmap scan report for specific IP address, host is up, and the latency information, and by default nmap will scan first 1000 ports. So as you can see, we have 13 ports open, so 1000 minus 13 is 187. As you can see, a default number of ports scanned by nmap is 1000, and upon scanning the 1000 ports, we found that 13 ports are open, and the state, and here we have 3 options: port, state, and service. So this is the port number, and these are the TCP ports. Under state, you have all options are open. There are 3 kinds of options. One is open, the other is filtered, and the last one is closed. When the state is open, it means that port is open and service is running, and the port is accepting the connections. Example, port 53 and port 80 are accepting the connections, so we have a state open, and the service information over here. Similarly, on 192.168.29.57, upon scanning the 1000 ports, we got almost 23 ports open, I guess. Okay, so these are all the open ports, and similarly we have all service information, and Nmap result for 192.168.29.157. We have a report. Host is up and the latency information. So 997 closed TCP ports. Rest are all open ports. Nearly 23 open ports. Port numbers, state all open, and service information. In both the cases, we got MAC address. Okay, so MAC address of 29.14 IP address and the MAC address of 29.157. And in the third window, we did Nmap scan for INSECTECHS.in domain, whose IP address is 88.99.99.104. As you can see, latency is 0.15 seconds. Host is up, and the reverse DNS record is Kaiser inet3net.net. So 900 filtered ports and port numbers that are open, state, and services. So these are the services that are running, like FTP, domain, HTTP, POP3, IMAP, HTTPS, and so on. So this is how you use Nmap to scan a single machine, a syntax to scan a single machine. Now that you know how to scan a single target machine using Nmap, the second one is, if you have a multiple targets like 2 different IP addresses or 2 different systems on internet or local network, you can use Nmap target 1 and target 2. Similarly, if you have a local network, you can use the third option, third syntax, target and CIDR, that is classless inter-domain routing /24/ notation. Okay. Similarly, if you have a list of specific IP addresses, you can save that IP addresses in some text file, and you must save the text file in Nmap folder. In order to scan multiple IP addresses, the command or syntax is nmap 192.168.29.14 and 192.168.29.157, and also I'll do 88, 99, 99, and 104. Hit enter. As you can see, Nmap is doing its job, scanning the individual IP addresses. So this is a scan report for 192.168.29.14. We got the information, open ports, state, and service. Similarly, this is a scan report for 192.168.29.157, and we got the information that we have seen earlier, and we were unable to get the MAC address of 88.99.99.104. And if you want to scan the entire subnet, the command is nmap 192.168.29.1//24, which is a subnet mask. So let me do if config. As you can see, the subnet mask is 255.255.255.0. So CIDR is /24, that is CIDR notation. Clear. Nmap 192.168.29.1/24. So it is going to scan the entire network. Hit enter, and this could take some time. Nmap is very noisy tool, and if you are doing scan on 88.99.99.104, firewalls or intrusion detection systems can raise an alarm. So this is Nmap scan report for entire network. Scan report for reliance.reliance, that is the host name for 192.168.29.1, which is my router. 29.14 is up, 29.55, which is the host machine, is up, 157 Metasploit is up, and 207, this is my own machine. So this is how you will use Nmap to scan the entire network. Now you can scan a specific IP address on a target machine by using the option P. Nmap-P, port number like 80, 8080, 443, 53, and so on. And similarly, you can also give the range of port numbers, not the entire port range, but say for example from port number 10 to 100 or 20 to 200, and so on. In order to scan a specified port, command or syntax is nmap-p option and the port number, say for example port 80, and the target IP 192.168.29. For example 55, which is a host machine. This is a host machine and port 80 is not open actually. So let me hit enter, and let me also type 14. Hit enter. As you can see, the Nmap result for 192.168.29.55, the TCP port is filtered. It means that Nmap is unable to tell whether the port is open or not. It is not open port, it is not closed, but the state of port is neither open nor closed. It is filtered. So you can say that Nmap is unable to say whether the port is open or firewall is blocking on port 80 So that is the reason we see that the state is filtered. And when you see Nmap result for 29.14, we see that state of port 80 is open. And let me repeat the command once again with port numbers 21, 443. Let me do it on 29.14, 80, 21, 23, 53, 443, 8080, and hit enter. As you can see, Nmap is starting and it tried to find whether all these ports are open or not. So we got the result. So port 21 is filtered state. So again the state is filtered. For port 23 also the state is filtered, while for 53, 80 and 443 ports are open and accepting the connections. By default, Nmap will try to establish a TCP connection. So as you can see, the state of ports on these three are open and the state of these two ports are filtered. So let me do the same on external IP address, www.insectechs.in, hit enter. As you can see, the Nmap is running and we have 4 open ports and 1 filtered. So we have given 5 port numbers to be scanned and we got 4 open and 1 filtered. In order to scan a range of ports, the syntax is nmap -p and the range 22.8080, target IP address, and hit enter. As you can see, the scan report for 29.157, these are all the open ports that you are seeing on the result. So this is how you scan a range of ports. Next we have OS fingerprinting -O. This flag enables OS detection, which attempts to identify the operating system of a target machine. We have done the port specification, right? So let me try that. Nmap -O and the target IP address. And Nmap is now scanning to find out the the operating system of the target machine. And as you can see, the host is up and this is the information that is Nmap has revealed upon the scanning. And as you can see, OS scan results may be unreliable, and aggressive scan OS guesses is Microsoft 2019 server, and it is likely 97% the answer is correct. No exact matches have been found, and the network distance hop is 1 because we are doing it on a local machine. Let me try that the same on 88, 99, 99 and 104. Let us see. Nmap -O 192, 168, 29.14, which is metasploitable. TCP IP fingerprinting OS scan result requires root privileges, not an issue. Hit enter. Here, as you can see on my INSECTECHS server, we got certain results like these are all the open ports, and the OS guess is Linux 4.4 version, which is again 97% likely. No exact matches for host. And here you can see again on a Linux metasploitable, the OS detection service from the Nmap has revealed a lot of information on all these ports. Sorry guys, there was a stray dog outside barking. Anyway, the result shows that the metasploitable system is running Linux 2.6 version, and then again the distance hop is 1, and OS details is 2.6.9. Here we got some X. So this is the option -O to find out the operating system of a target machine. You can actually give the range as well. Okay, so let me repeat the same command once again on 15, nmap 15. So here we are doing only OS fingerprinting scan, but here what I'm giving is another option called as V, which is Verboros. So Verboros tells the depth of the information that Nmap gives, or we can give 2 V's to give more details. So we can increase up to 4 also to get more and more details. So let me try with the V option over here and let us compare both the results. As you can see over here, Nmap is trying to scan or dig as much information as possible. So as you can see clearly, the output of the Nmap scan, when you have mentioned -V option over here, so it is actually revealing what it has done, what scan it has done. And although the information is nearly same, but the output, displayed output is different. So let me try the same with 2 more V's. Now compare both the results. So as you can see and compare both the outputs with a single V option, single verbose option, and 3 verbose, the depth of the information that has revealed, you can compare. So we have, if you see the bottom, we'll have MAC address, OS type detection, that is 97% 2017 and so on. But so here, as you can see, we got little more information of TCP/IP fingerprint, which was not there in this scan type. So this is how you can use the V option. Next, -O, small o, you can actually save the scan results of Nmap scanning to an external file. Say for example Nmap small o and 192.14. Hit enter. Sorry, I should mention the file name, right? Outfile.txt. Hit enter. Now if I type ls, you can see there's a file called outfile.txt, and you can read the content of the file. Hit enter, and this is the scan results that you have saved to the file name called outfile.txt.
So these are very basics about Nmap. Now let us try to understand how we can use Nmap very effectively. There are a couple of types of scanning techniques. Before understanding them, let us try to understand what is three-way handshake. If we have two systems, in order for these two systems to communicate, they have to establish a connection. To establish the connection, first client will send SYN packet to the host, and host will reply with SYNAC packet. And the third step is the client will reply back to the host by sending this ACK packet. Once if these three packets are exchanged, now it establishes a TCP connection, and this is called three-way handshake. And the Nmap works based on this handshake process. Nmap tries to send some packets to the target, and based on the responses it is getting, it will decide what are the ports open, what are the services that are being run on the target system, and so on. Now let us try to understand a few Nmap scan techniques. The first one is TCP connect scan, or this is also called as full open scan. It completes the normal TCP three-way handshake process just now we have seen. It means this particular TCP connect scan works based on TCP three-way handshake process, and it requires the system call which is connect off. To understand the information about the target, it uses the system call connect. If the port is open, this connect command will work, else this command connect command will be unreachable. This is how this TCP connect technique works. And the disadvantage of this particular TCP connect scan is it can find only TCP ports but not UDP ports. And this is the default scan technique for Nmap.
So the syntax for TCP connect scan is using option -S and T. Before that, let me show you man Nmap. So this is the very good manual for Nmap network exploration tool and security port scanner, and you have all the information of all the options over here, as you can see. So if you want to get or grab information of a particular option, you can use man Nmap grep -I and inside double quotes you give the option, for example S and T. Hit enter, as you can see, and Nmap -s and capital T, and the target IP address is 192.168.29.14. This is a TCP connect scan. But before that, let me clear the screen once and allow me to do a normal Nmap scan. Nmap and 192.168.29.14. Hit enter, and let me also do the same Nmap. Now I'll use TCP connect scan -ST 192.168.29.14. So compare both the results over here. So we got almost same results. Okay, so if you check the result is almost identical over here. Okay, so by default, even if you don't specify -ST, Nmap is going to do a TCP connect scan only. Let me do the TCP connect scan Nmap on external IP -ST This could take some time, so you have to wait, because Nmap is scanning all the ports and it is trying to establish connection with the ports, so it will take some time. So as you can see, we have a results of TCP connect scan on 88, 99, 99, 104. So 900 filtered ports. State of all these ports are open, and these are all the open ports. And now let me actually minimize this window. Let me start Wireshark. So let me open the Wireshark application. It is a network protocol analyzer. So it helps us what is happening exactly in the background when my computer is communicating with another computer, a target computer. So let me type the nmap command, nmap-st, and target machine is 192.168.14, which is a Windows server. And now let me open the Wireshark application. This is to understand how Nmap is working in the background. So welcome to Wireshark. So let me hit on the shark fin icon to start capturing the packets. Click on it and now hit enter over here. Hit enter. As you can see, there are a lot of ports which are open. So let me stop the Wireshark right now. Let us target only a single open port because there is a lot of traffic here over there. So let me retype the command once again and let me give the port number. Like you have 80 as an open port. We will see responses of both open ports and closed ports. So let me type P and port number 80. So let me restart the Wireshark once again. Start, continue without saving. Now hit enter over here. As you can see, we have TCP port 80 open, and let me stop the Wireshark. Stop. Now let us analyze the packets using the Wireshark. Now we have to apply the filters. You have a lot of filters in the Wireshark to narrow the search results because there is a lot of traffic that is being captured by the Wireshark on your system. Okay, so let me apply the filter ip.adder is equal to 192.168.29.14. Hit enter. Now we have a limited packets that you can actually analyze. So what happens in TCP connect or full open scan is the scenario is something like this. Attacker is sending a SYN packet to a target machine, and target enables SYN and ACK flags in the packet, and then that will send ACK packet enabled in his packet. Then again attacker will send reset and ACK packet. So this is a scenario of a TCP connect scan, or you can call as a full open scan. So let me check in the Wireshark, is this going on in the background? So let me type one more filter and tcp.stream, because we have to follow a certain stream where stream sequence number should be equal to 0. Okay, 0, hit enter. So as you can see over here, from my machine 63 to 14 source and destination, and from my source port is 42612 and the destination port is 80 because we are doing TCP connect scan targeted on port 80 only. So the target port is 80 and SYN is enabled, and we got a response from a 14 to 63. Now the source IP is 14 and the destination IP is 63, that is my machine, and the source port is 80 and the destination port is 42612, and we have two flags enabled, SYN and ACK. Again from 63 to 14, which is source IP and destination IP is 14, we are sending only ACK enabled. After that the communication should be going on in general, but because this is a Nmap TCP connect scan, again the system 63 is sending reset flag and ACK flag enabled in its packet. So let me show you. Double click on the packet number 3. So 3, 5, 7 and 8. Double click. As you can see, transmission control protocol source port is 42612 and the destination port is I am sending is port 80, and the source IP and destination IP. As you can see over here, let me click on arrow to drop down the conversation, and as you can see the flag SYN is enabled. Let me close this, and the next packet in the conversation is packet number 5. Double click on it, and as you can see now we have from source port which is 80 of a target machine, now that has become a source port, and the destination port in the next packet in the conversation is my machine, which is 42612, and as you can see SYN and ACK is enabled. Okay, and this is how you can click on the each packet and check what is going on in the background. So Wireshark is useful to understand how a network communication is going on. Okay, so let me close this. So this is a scenario of an open port. So let me do the same thing. Let me close this and restart the Wireshark once again. Let me do the same thing on a closed port as well. So let me type nmap-st. Source port is, sorry, the target port is 1000 for example. So let me check whether the port is closed. Yes, the port is closed and some Cadillac service. So I haven't not captured the packets yet. So this is the scenario of open port. So what is the scenario of a closed port? We'll see. Start the Wireshark, and now let me repeat the same command. Hit enter. So let me stop the Wireshark once again, and the filter is IP header 192.168.29.14, as well as I'll also select the TCP stream equal to 0. Okay, hit enter. Now as you can see, where is sequence number 0? Sequence 0, but this is a port 80, but we want port number 1000. Okay, let me drag this side. So sequence 0 and from my machine 63 to 14 on a target port. So my source port is 48176 and the target port is 1000 and SYN packet is enabled. Next we have from the machine 29.14, which is a closed port. System is up but the port is closed, which is 29.14. We have a reset and ACK enabled. So let me click over here, right click, follow TCP stream. We don't want this. So we now have two packets from my machine, that is from 63 to 14 on a port 1000. We are sending a SYN packet. However, 14 is sending us back to our port number 48176, a reset and ACK flag enabled. So this is a scenario of a closed port. So guys, whenever we are doing another scan techniques, whether we are doing UDP scan, stealth scan, please enable the Wireshark and capture the packets and test yourself. So what exactly is going on to understand the Nmap scanning techniques.
And the next type of scan technique is SYN stealth scan. This is also called half open scan. This SYN stealth scan is known as half open scan because it doesn't establish a full TCP handshake with the target system, and it doesn't create any session on the target, so that the logs will not be created on the target system. That the scans that we are performing, that relate associated logs will not be logged on the target system. This is the advantage with this SYN stealth scan, and usage is Nmap-S capital S target.
So let us do the stealth scan or half open scan. Nmap-S and capital S and target 192.168.29.15 and hit enter. And before that, let me start the Wireshark as well. So have a practice of analyzing the traffic with a Wireshark. Start and hit enter. We are more concerned on the result over here. Okay, so let me stop the Wireshark. Stop. So upon doing the stealth scan, we got almost same results, nothing else, just like a MAC address and the open ports. Not just first 1000, but we also got showing the ports 53573269, which are open ports in this case. So this is a stealth scan, and what happens in the stealth scan is that for open ports, attacker will send SYN pack and the target will send SYN-ACK. Then attacker will send a reset flag for open ports. But if a port is closed, the target will send a reset ACK when attacker sends a SYN flag. So let me open the Wireshark and let me apply the filter. IP.header is equal to 192.168.14. Hit enter. Sorry, it's 15. So you can now analyze the Wireshark results for half open scan, but we have not mentioned the port over here. So let me do the SYN stealth scan on specific port only, and port 80. And now let us restart the Wireshark. Continue without saving. Hit enter. And that's it. Stop. So as you can see, SYN, SYN-ACK and reset, right? SYN, SYN-ACK and reset. So we'll do the same on a closed port as well, but we are more interested in the results that we got when we have done Nmap SYN stealth scan on port 80. On port 80, we got that port is open, scan timing, scan IP address, latency and the MAC address. Nothing much information has been revealed using a SYN scan. So let me start on some random port number 3289. This is a closed port, but forgot to start the Wireshark. So let me hit once again on 14. Hit enter. So we have sent a SYN packet and we got a response, reset with acknowledgement. So as you can see over here, when an attacker sent a SYN enabled on a closed port, the response is reset with acknowledgement.
And the next one is UDP scanning. As we discussed in TCP Connect scan, it can be used only for TCP ports. If you want to scan for UDP ports, you can use this UDP scanning. So it doesn't require any SYN packet to be sent. Since we are not going to scan any TCP ports, it doesn't require any SYN packet. And this works by sending UDP packets to the target machine and waits for a response. And if the port is closed, it will send an ICMP unreachable error, so that this particular scan technique will decide that this particular port is closed. And if it is not getting any error from that, if it is getting a positive response, then it will decide that that particular port is opened.
So let me perform the UDP scan. Nmap -su. Let me do it on my INSECTECHS machine and hit enter. I'm not giving any port specifications, so let me hit enter. Let me do the same. Nmap 15, not an issue. As you can see, we have a Nmap scan result for UDP ports or UDP scan. So port 53, UDP port 53 is open, UDP 88 is open, and we have all these open ports and not much other information except we got a MAC address, which we already got earlier while doing the TCP scans, full open and half open scan, still scan. So let me wait for the results of UDP scan on insectechs.in. It is really taking a long time. Let me hit cancel and do a port specification. 21 to 500, and as you can see the result, UDP port 21 is closed, however UDP port 53 is open. So this is an open port and UDP port 8 is closed. So let me turn on the Wireshark. As you can see, when we done Nmap scan on 29.15, it took 5.69 seconds, but for ports from 21 to 500 on insectechs.in, it took almost 15 seconds. So when actually I did Nmap scan on same INSECTECHS.in, it was taking long time. It was actually scanning all the UDP ports. So let me start the Wireshark once again, and now let me specify only port 53, which is actually open port. So when you actually do a Nmap scan on open ports, we send UDP packet and the target machine will send UDP plus data packets, something like this. So attacker is sending, or a normal user is sending UDP packets and UDP plus data is written. However, in the case of closed ports UDP scan, attacker or normal person is sending UDP packets, and if the port is closed, like for example port 80 was closed, so it will obviously send ICMP port unreachable. So let me show it on a port 53, which is an open port. Start the Wireshark and hit enter. So as you can see, we have captured the packets. Let me hit on the stop capturing the packets. Now my filter is IP.header 88.99.99.104. Now as you can see, after applying the filter, our source IP 192.168.29.63 has sent some UDP packets, and we got a reply from 99.99.104 with some data packets. So let me do on a closed port. So port 80 is closed. So let me repeat the same, port 80, and let me restart the Wireshark. Hit enter, and as you can see, we got a result. Now when you actually see the scan results once again, here as you can see the mark, so the source 29.63 has sent a UDP packet to a destination 88.99.99.104, and we got destination port unreachable. Okay.
The next scan technique is Fin Stealth Scan. It is very interesting scan technique and also very important one. If the target is behind a firewall and if it is blocking SYN packets, this particular scan technique will send data packets with fin flag set. So if the port is open, it would not send any data packet back, while if it is closed, it will reply back with a fin packet, so that we will come to know that this particular port is opened. This is very efficient if the target is behind a firewall and if it is not allowing you to send SYN packets to the target. And to use this command, you can simply type nmap -s capital F target's IP address.
So the command to perform synscan is nmap. It's not synscan, it's a finscan as F, and let me do it on 192.168.29.15 and let me hit enter. So nmap is scanning. It may take some time because it is going to scan on all the ports. I should have started the Wireshark, so let me start now. So as you can see, nmap is sending fin flag enabled to all the ports. From my port, which is my source port, is 41484 to all different ports. So let me stop the Wireshark. So we'll target specific port to understand what is actually going behind Wireshark. So nmap sf, let me do it on a port number 80 and let me start the Wireshark. Hit enter. So let me stop now and let me apply the filter as TCP protocols. So as you can see, on a port 80 we are sending a fin flag, and when the port is actually open, because on this server, which is Windows Server, port 80 is open. So when you are sending a fin flag enabled in your packet, TCP packet, the server or a target machine is not going to respond anything. Okay, so this is how nmap finscan works. So let me do it on a closed port as well. Okay, port 3389 192.29.14, which is metasploitable, and let me hit enter. Before that, let me start the Wireshark. Hit enter. So as you can see, this is a closed port, and when we have sent a fin scan from our machine 29.63 to 29.14, when a fin flag is enabled, the server, the target machine or a metasploitable server has responded to our machine with reset and acknowledgement. Okay.
The next scan technique is idle scan. It is very important scan technique and very interesting one. We can perform anonymous scanning using this idle scan technique. We have a target network and we are going to scan one system in the target network. We can spoof our IP address by using some other host's IP address in the same target network. Here, this is the command we have to use: nmap -si zombie host and target host. Zombie host is the spoofed IP address and target host is the IP address you want to scan.
So as Mr. Srinivas said, idle scan is really interesting. This scan is also sometimes called as truly blind TCP port scan. Means no packets are actually sent from attacker's IP, I mean your IP address, if you are doing that. Instead, a unique what is called as a side channel attack is performed by the attacker by actually predicting the IP fragmentation ID, which is actually a sequence number, on the spoofed IP which you want to use as a zombie or zombie machine, and it is done to find the open ports on a target machine. In general, to find the open ports, what you do is you send a SYN packet to get SYNAC in response and reset if the port is closed. But in this conversation, there is something called as a fragmentation identification, which is actually called IP ID, and it is always incremented by 1 in the value. So if you probe for IP ID, you can guess how many packets are sent since last probe. Okay, so to find the open ports on a target machine, assuming this scenario as a port is open, the attacker will probe for IP ID of a zombie machine or a zombie PC by sending a SYNAC packet or SYNAC flags enabled in the packet. As you can see here in the screen, the attacker has sent SYNAC packet to zombie machine whose IP address is 29.157. Now what will a zombie machine do? It is confused because it has not get a SYN packet initially. Directly it is getting a SYNAC, so it get confused and it will send a reset flag in its packet with IP ID. In this case, the example is 369. Now assume this step as step 1, what attacker has done. Now the step 2 is the attacker will forge a SYN packet, means attacker will send a packet to a target machine as if it is coming from a zombie machine and it has a SYN flag enabled. So this is a forged packet. Since now zombie has sent a SYN packet to target machine, which is actually not true, the target will send SYN-ACK to a zombie machine. Now zombie will get confused because it got second time SYN-ACK packet in a row. So zombie thinks it is a bad day or it did not get coffee properly. It will again send a reset packet with IP ID in its in the packet, and now the IP ID is incremented by 1. So the IP ID is 370. Now assume the step 2 is completed. Since the attacker has initiated this idle scan or zombie scan, he knows the IP ID of a packet that it has received from the zombie because he actually initiated the attack. But he don't know the IP ID of the zombie it has sent to a target machine, right? He know the IP ID of zombie it has received, hacker has received, but what IP ID the target has received, the attacker don't know. Please keep this key point in your mind right now. Now the step 3. The attacker will again send a SYN-ACK packet to a zombie. The zombie machine gets crazy like me, but it has to follow the protocols. It will again send reset flag in the packet, and the IP ID will be 371. Now 371 is 2 times incremented since the first initiative or first when the attack was initiated. If IP ID plus 2, that is 371, is received and attacker knows this value, then he can confirm that the port is open. Okay, and if port was closed, he should have received IP ID with 370 only. So let us now do the same on a closed port, or understand on a closed port. Now in the scenario of a closed port, the step 1 is attacker is sending a SYN-ACK flags enabled in its packet to a zombie machine. So obviously zombie will send a reset flag with IP ID 369. Step 1 is completed. So now the step 2 is that attacker will send a forged packet of a zombie with SYN flag enabled to target machine. Since the port is closed on the target machine, example port could be 80 or any other port. Since the port is closed, the machine will respond to zombie machine with a reset flag enabled in its packet. So zombie received a reset flag and it will do nothing. Now attacker will again, this is the step 3, attacker will again send a SYN-ACK packet to a zombie machine. So confused zombie will send a reset flag. Now the reset flag has IP ID, the packet has IP ID 370 incremented by 1 only. In the case of open port, this reset was second time when he actually sent a SYN-ACK to a zombie. The reset IP ID was 371. So attacker can calculate that the port was open. But since now he knows that the IP ID value is incremented by only 1 only, from 369 to 370, he comes to conclusion that the port is closed on a target machine. So this is called as idle scan or idle zombie scan. So let me perform idle scan on my network, and as you can see over here, I have did a ping scan using as an option on my target network, and I have 8 computers up and running, one of which is a target machine and one is attacker. So I have 6 remaining which can be used as a zombie. But you cannot use simply a live machine as a zombie. It has an eligibility, and the eligibility is that the computer must be supporting the incremental IP ID sequence. Okay, so how to find whether the computer which is live and running has incremental IP ID sequence? You can find out that by using again the Nmap scripts that you have, and type ls. So under root user share Nmap folder, there is a scripts folder. In the scripts, there is a script called as a IPID sequence.nse. So there is a script. Now you have to find out which IP has eligibility to be fit as a zombie machine. The command is nmap scripts and IPID sequence on your network block, target network block or your network block. Hit enter and wait. As you can see the result, we have a lot of machines, right, which are up and running. IP ID all zeros for IP 192.168.29.1. IP ID sequence all zeros. This is not supported. For 129.8, 192.168.29.8, IP ID sequence is unknown. not valid or does not fit to be a zombie. And again 29.14, which is Windows Server 2019, has IP ID sequence all zeros. Again, it has not eligibility to fit as a zombie. Now this is incremental. This fits as a zombie machine, which is IP address 192.168.29.15, which is Windows 2019 server. Actually, this is metasploitable, which has all zeros, but this is a target machine. So let us change the target. That's not an issue. So this fits as a zombie machine. Let us see. Even 29.55 has IP ID sequence incremental. Even this computer, both Windows computers 29.15 and 29.55 has IP ID incremental. So these both fit to be a zombie machine. So let us perform now the ideal scan on target machine. So now the target is 192.168.29. Let us change the target to a metasploitable, okay, 29.14, and I'll use 29.15 as a zombie. So now let us run idle scan, clear, and the command is nmap-s capital I zombie IP 192.29.15, and let me remove the host discovery pn and -n, and the target IP 192.168.29.14. Hit enter. Let me perform again. In both the scenarios, probe failures are going on. It is down or there could be a firewall, okay. So since the zombie was 15, which is server 2019, maybe a firewall is blocking. So let me change or use another machine as a zombie. Now I will use 55. Hit enter. So even this time also I could not get anything. So God help you guys, because I don't have any other machines that are fit to be as a zombie. There is no IP ID incremental sequence. So that's it in this class, but this is the command to initiate a zombie scan in your local target network. So the next scan is version detection scan. So Nmap version detection often refers to as a service version detection. It is a feature of Nmap that allows you to identify specific versions of a network services. Means there are different services running on different ports, so it's a kind of a version detection. So let us do the Nmap version detection scan. Ideal scan didn't work out over here. Clear the screen. Nmap -sv and the target IP address 192.168.29.14, which is metasploitable. Hit enter. Nmap SV 192.168.29.15. okay, so this is on 14 and this is on 15, which is server 2019. So as you can see, port 21 is open, FTP service is running, and the version detection has done. Port 22 SSH and the version detection open SSH 4.7 P1 Debian. So as you can see the services and version detection of that application, okay, as you can see. Scan report for 29.15, which is predator DC Windows computer or Windows server. It has port 53 open, simple DNS, no version has been detected, port 80 Microsoft IIS HTTP 10.0, and so on. So guys, that's it in this Nmap class. In the next class we will see a lazy guys tool called Nmap, which is actually GUI version of Nmap. Have a great day guys. Thank you. Thank you for watching the video, and do subscribe to the YouTube channel INSECTECHS.